Hello and welcome to this session called Vaadin in Practice. And yes, my name is Aleksandr and I work for Magnolia development team. I do this and that, but among my responsibilities is a lot of Vaadin development. And today I would like to share some insights about that with you. So, by the way, how many of you know at least the basics of Vaadin, like how it works? Nice. Any of you maybe have ever created a component, like a full-blown one with client-side and everything? Yay! Cool. But yes, for others, I guess it's a lucky day, because today we're going to talk about the component mechanics, how components interact in terms of client-server communication with each other. We're going to take a look what Vaadin extensions are, how they're related to components, and what are they? And if time allows, we will sneak peek into declarative layouting, the quite recent feature of Vaadin, and also do some demos. Okay, but first let us recap what Vaadin framework basically is. I hope that more or less everybody knows that it's a server-side Java single-page application framework, meaning that it keeps also the UI state besides the business logic on the server side. Vaadin uses Google Web Toolkit as a rendering engine on the client side and also as a layer for some communication magic. And Vaadin is heavily oriented on business applications. It's secure and it integrates well with the enterprise Java stack. But the killer feature is Vaadin's really simple coding flow, like you see on the screen, where we have practically something identical to a desktop application, but it's actually a web application, and here's the result in the browser. So we have a layout with a couple of components, like a button and a text field, and some interaction between them. It's a simple one, but it works, and what you've seen on the previous screen is more or less enough to hack this app together and start playing with it. Yeah, Vaadin offers a lot of components. So basically, it has everything needed for a typical enterprise application out of the box, like controls, fields, tabular components, grids, and also, of course, connectors and containers that would allow to help that help with data binding. But sometimes some projects require some special needs, like us, for instance, because we wanted to have a really beautiful CMS and we wanted to go a bit beyond what Vaadin offers in terms of component set. So we created components like a page editor, which is actually a Vaadin component developed by us, and you know what it does, and it's pretty heavy, and it was quite a lot of work, but we managed to accomplish it and we ship it. But yeah, we have smaller components like action bars, fields, dialogues are also custom Vaadin components. So I think we know a thing or two about that. And today we actually going to speak about how the basics about how to develop such components yourself. And I will mention that these days it's actually possible to use Google Web Toolkit as a view layer for custom components, but also one can develop components in JavaScript, which is much easier in many ways, especially in terms of maintaining and shipping those components, because we won't cover it today, but if you develop with Google Web Toolkit, you need to conduct several further steps before your users and even software developers can use what you have created. But anyway, let's take a look how components are created, at least with JavaScript. So on this awesome video, you can see something that I have created a while ago. This is a totally custom component called App Switcher. And what it does is, in the sense of, in a way of OS X dock component, it gives you a pop-up and allows to switch between running apps in Magnolia through with mouse or with shift or with arrow keys. And it's implemented mostly in JavaScript. It only has a communication layer on the server side with Vaadin, but it's mostly a JavaScript component, because primarily I wanted it to be as snappy and as smooth as possible. For that, I had to move more and more logic to the client, like mouse handling events, shortcut events, and etc., and only communicate the essential part of the server side. So that's why you can see even on the video that it's pretty fast. But so how do we do that? So we somehow have a component on the server side. Somewhere we have JavaScript or Google Web Toolkit widget. So how to implement that? And this diagram aims to show actually how. So imagine that we have this app switcher on the server side, and you would use it the same way as you would use a button or a text field. You would put it in a layout, you would create some Vaadin view out of it, and then there is actual view. Looks like this, implemented in JavaScript. But how do they talk to each other? And apparently there is a thing called component connector. It's a part of API introduced in Vaadin 7, and it acts as first of all as a presenter for the view, meaning that it orchestrates the hierarchy of the view components, and it knows when to trigger this view state update, and sets the properties, and etc., etc. But also, it acts as a counterpart for our Vaadin component on the server side. They both share the same component ID, and they are connected with an annotation or a bit differently in JavaScript. But anyway, Vaadin knows that on the server side we have this app switcher. On the client side we have a component connector for it, possibly called like app switcher connector. And those two communicate with each other in two ways. First of all, there is a shared state. It's an object, a simple Java POJO, which allows to, in a nice way, to keep a set of properties that are essential for your component and communicate them from server to client. So server side keeps the state. It allows programmer to modify the state. Then whenever the request is handled, the Vaadin will compute the difference and send it to the client. And then client gets it. It gets notified that, yeah, this property has changed, for instance, the caption of a button. And then the component connector will actually set the caption onto the DOM element. So as simple as that. And it's very powerful because shared state, we will actually take a look what it is in a closer look later on in the demo, but shared state actually keeps all the information necessary about the component on the server side. So if I reload the browser page, then but still I have the session on the server, my components that are kept there will be restored by Vaadin because it knows all the necessary information about them from the state. But only problem here is that the communication happens in one way. So it's only possible to notify client side that something happened on the server side. But if you want to notify other way around, then there is RPC mechanism, which is a really that simple interface that one wants to expose on one side and communicate through it to the other side. It's stateless, so it will not affect the state whatsoever, but it's very handy to communicate, especially from client side to server side. When you click a button and you want to send some information about a button click, then it's that simple to do that. But now we can return to initial snippet that I've shown to you and see a bit in more details how actually communication works. So here we have a layout, text field, and a button. And imagine that we click a button. So there is, hopefully the video is running. Yes, the button is being clicked, the label is being added. And how that happens? So first of all, you can see that we have an hierarchy of components. The UI is the root of Vaadin app. It has the connector ID 0, and all of them are labeled. That's the ID through which the communication happens, and so that both counterparts know about each other. And then we have a root layout, text, and the button. And then when we click a button, the label is added. So when we actually click a button, you can see, hopefully you can see that there is a JSON payload being sent from client to server, and it reads that button server RPC click and all the details. It's only a piece of JSON. And then the server side gets that and synchronously processes this request. And then as a result, we get another component added with ID 4, which would be a label with its state, only two properties set, the caption and the width. And also we see that the hierarchy for layout has changed. And then this response is communicated back to the client, and then client handles that. Yes. So yeah, as you can see, that's the approximate sequence how it happens on the client side. So it would then handle all the shared state requests in the order of their appearance from the server side. Should there be any RPC invocations, it would invoke them, but not in our case. Then all the hierarchy changes are also handled so that Vaadin client-side component connectors will get events that this hierarchy has changed. So component connector responsible for this component will rearrange the view and toss the elements back and forth and maybe throw out some grid widgets or add new ones. So yeah, that's how it happens. And eventually, Vaadin actually has a powerful layout manager mechanism which will run the layout phases automatically later on and get the view into shape. Yes, and that's pretty much how the communication in Vaadin components actually works. It's very basic because we're a bit limited on time, but that's more or less what you need to know how it works under the hood, so to understand this magic. One thing that I wanted to show, to explain before we move on with the demo, is a bit of trickery that you might see, you might notice that in order to set up communication, in order to establish the message passing back and forth, we actually have to have components. And components are initiators and the receivers of the message from the client side and to the client side. But sometimes we actually need something different. So we don't want a new component, but we want new functionality. For instance, we want client side to ping server side every now and then just so that it would refresh its state and send the changes back and forth. For that, we don't need a component. But we still want the communication. And that's when Vaadin extensions kick in. So what is Vaadin extension? It's somewhat like a component, but maybe without a UI. So like component attaches to a layout, extension attaches to a component itself. And here we see an example of our own built extension called jcrop. Well, jcrop integration. So we take a Vaadin image component and attach an extension on top of it. So, to give that's how it basically happens. Like some layout add component, jcrop extend image, and that means that we get sort of a new component on top of another, and their life cycles will be synchronized so that when changes of the component are communicated to the server, its extensions changes are also communicated together. It's very essential. It's a powerful technique because it encourages using of proper patterns, shall we say. Like instead of inheritance, you can use composition. And actually, yesterday it occurred to me that Vaadin extensions are somewhat like headcrabs from Half-Life, because they actually attach to a host component and they modify the behavior of the host, and their life cycles are connected. But on the other hand, unlike headcrab, you can attach as many as you want, and you can also remove them without any bad effect on the host. Yes, and they are very similar, as I said, to components, and usually serve for good intentions. But right now, I would like actually to implement one extension and show you how one can easily add something new to Magnolia user interface. It's not going to be a very serious demo because of the time limits, but it's going to be a funny one, I hope, if I manage to keep up with the live coding. But anyway, once I was browsing interwebs, and I have encountered a real good piece of wisdom that any web app would be so much better if there would be some dinosaurs in there. And right now, we're just going to add some to Magnolia. I'll quickly switch to IDE, and then we will see how easy it is to develop an extension. So for that, I have created a module called RaptorIser, and it's currently quite empty. It has an empty package, and all it has is a resource, a jQuery plugin that the inventors of that idea have supplied as a starter kit to make the web apps awesome. And right now I'm going to integrate this jQuery plugin into Magnolia with Vaadin. So let us begin. First of all, let us create an extension, and we'll call it RaptorIser. Java. Oh, I need to set my folder as a... yes, sources root. So yes. Okay. So we create an extension called RaptorIser, which would extend abstract JavaScript extension. That's the entry point for all such components that would involve some JavaScript and extend some UI. And we will add a method that would allow a factor method that would allow somewhere to take a UI instance, which in our case would be the whole AdminCentral root component, and add a RaptorIser extension to it. Also, we will attach a script to our extension, like this. So this add JavaScript annotation means that whenever Vaadin will attach my extension to the connector hierarchy, will attach to component, this script is going to be loaded together with the component. It's going to appear on top of the page. So we can rely that whenever we hit the client-side initialization of our extension, then this script is going to be available there. Yes, but now let's start coding some JavaScript on our own. So for that, we will create a JavaScript connector. We will call it RaptorIser connector, and we'll create that script right away. So I created JavaScript, call it RaptorIser connector, and here it is. Okay, so let us see how it looks. So to save some time, I prepared some snippets. And here's how it looks initially. So look at the name. By convention, if you want to attach a JavaScript connector to Vaadin component on the server side, it has to resemble its fully qualified class name, but dots replaced with underscores. If it would be Java, then we would be using @connect annotation. So that's how it happens. And then several variables like self-reference and also connector IDs, which would allow us to query the elements of corresponding Vaadin components already on the client side. So right now, what I want to do is I would like to query the element of a parent connector ID of a parent connector, which is actually the AdminCentral UI, and RaptorIze it. So RaptorIze means like attach this plugin to the element. However, by design, RaptorIzer would actually expect several options for us to provide, and those options would be the image of a raptor, its sound they would produce, so that all the cool thing would happen, and a handle, so that we could start let Raptor go on our UI. We have the handle, but we don't have neither sound nor image, and those we will provide from the server side through shared state. And let us just create a class called RaptorIser state, and it would extend JavaScript state, JavaScript extension state. It's a simple POJ. Underneath it just bundles several properties, but that's not usually even interesting. What interests us is that we will ship two properties with our state, the image and the sound. And here in our extension, we simply specify that our extension provides this type of shared state. We override the getState method and tell Vaadin that here's the type I want to get. Vaadin later will create an instance with reflection, so we don't have to worry about any other boilerplate code. And then we will add API methods, the setters, so that we can alter this state from the outside. Notice this getState method that would actually provide us the instance of a state, but also mark a component as dirty. So when the response is being prepared, Vaadin will know which component it has to check for state modifications. So it tracks the dirty state of them. Okay, so now our API is almost set. Here on the client side, we can actually also have similar API with this .getState and Raptor image. this get state Raptor sound. And that will be it. That's how we ship the URLs of image and sound from client to server. No extra actions are needed. But now all we need to do is to be able to trigger Raptor from server side on the client side after some events occur. And for that, we will use RPC, the one that goes from server to client. And we will create a RaptorIser client RPC for that. It will, it actually should be an interface. Client RPC. This is an empty just a marker interface. All the rest is up to us what interface we want to expose from client side to server side. And in this case, I will only have one method called unleash Raptor. That would magically trigger the beast to enter our UI. And we'll add corresponding method to the extension. It looks like this. So it's an API method, and then in order to obtain the interface, the implementation of RPC interface, I call a method called getRPCProxy. Under the hood, Vaadin would generate a Java proxy that would delegate my call to the communication layer and then serialize it to JSON and then dispatch it to client side. So, but I don't have to worry about that. That all happens automatically. All I actually have to worry about is to provide an implementation for this interface, and we provide it in JavaScript, like this. We call also standard method called register RPC, and then we provide the functions by mapped to a name, to a handle by which they should be invoked. In Java, there'll be more type safe. We would specify which type of RPC actually we want to implement, but here that's enough. So, and as you can see, I have registered a callback. So whenever from the server side somebody tried to invoke a remote call with name unleash Raptor by timeout, I would unleash Raptor by handle. And that's it. So I hope that I didn't make no mistakes and it works. All we need to do is just to add some Magnolia glue. And for that, we will add a class called RaptorIser starter. And it's going to be a bean in Magnolia. Simple one. So it's it's going to be a singleton that would be invoked, created every time an instance of AdminCentral would be instantiated. Effectively, whenever somebody opens a tab with Magnolia inside. And what we're going to do is we're going to actually raptorize that UI instance, just like this. So you can see that we create an instance of RaptorIser, take a current UI instance, which is AdminCentral instance, and attach our extension to it. Then we also provide the resources module, because you can see that actually the image is stored already in our module, so it's exposed to our resources mechanism. So I can just take a download path and attach a relative path in my module and get the URL of an image and of the sound. And then I simply attach to an event bus. I inject the AdminCentral event bus. It's that type of event bus that that can allow communication between apps and between different components within the whole AdminCentral instance. And I say that whenever there is app lifecycle event and the app is actually started and that app is pages, and I unleash the Raptor. And now I will just recompile the code. It looks like everything went successfully. Oh, yeah, that's all right.
Welcome to VoiceOver.
No.
VoiceOver speak.
That's not what I wanted. Then I restart my Magnolia. And then imagine your colleague goes to a Pages app. And the Raptor now owns the app, so probably there's not much work to be done there. All right, it worked. Yay. So I stop mirroring and return back to... No, that's not what I wanted to do. OK, so back to keynotes. So I think you all agree that with the Velociraptor, things are much better. Why can't I? OK. Yes. Well, I don't know why I couldn't proceed, but I have one more topic that I wanted to talk about, and it's called declarative layout in Vaadin. As you can see here, I have this nice gentleman. His name is Thomas Jefferson. And some time ago, he was a president of the United States of America, and he thought that it might be nice to separate the church from the state. And then some other people thought that there are some other things to separate from each other, and one of those is the view and the business logic. And I again want to go back to the snippet that we've seen in the beginning with our nice swing-like code snippet with layouts and composition. And here I just tried to estimate the signal-to-noise ratio, and I came to the conclusion that this is mostly noise, actually. Because all this logic, like creating a layout, setting a caption, setting that we need a margin, that's it's OK, and it's very expressive, and one can understand it easily, but still it's noise. So for those who understand how things work, only this line actually makes sense, so meaning that there's a button and it has some sort of interaction and something happens when somebody clicks it. All the rest makes little sense. And Vaadin team thought about that even before, and what they came up with is called declarative layout, designs also they're called, and what it means is in front of your eyes. So one can describe the hierarchy of components directly in dialect of HTML5, and then read those files in their Java code and get the actual Vaadin components generated. This piece of code should show how it looks like. So we can see that there is a view, extends some vertical layout, and then there are some fields declared in this class, like a text field, a password field, and a button. And then in the constructor, you can see they call design.readThis, which means that, from Vaadin point of view, through some conventions, that there is a markup file, like we've just seen above, stored somewhere in the class path nearby, probably in the same package. And with this annotation, it would say that, well, when parsing this file, please create some Vaadin components, set the reference to the root component to this class, and inject everything else. So here we can see that there are IDs like ID, password field, email field, and etc. And by field names, it will create those components and directly sort of inject or assign them. So you don't even have to call a constructor. So this snippet won't actually fail with NPE, it will work. And you can see that the amount of noise here is lowered dramatically, so you don't have to care about the UI, you only care about the business logic, and that's it. But since we have this light development initiative going on, I was thinking that it would be a shame not to try to hack it into this concept, and I came up with yet another demo. And I wanted to show how it works. So what I did is I went a bit further. You have seen how to inject fields. I managed to hook to this process of parsing the HTML file and generate some fields on the fly. So, but it's maybe easier to show than to explain. Yes. So, and meet the contact browser app. It's a simple what's that, master detail app that loads the content from the contacts workspace and provides some auto-generated form, and then we can we can save changes. They automatically go to JCR, and everything's good. But now I close this app and go to resources. And there I have this modules called layout demos, and here's the resources available from it. And here's actually a layout of the app that I've just shown. And for instance, I want to get rid of the website field, or even better, I want. Oh no, that's not that what I wanted. I want to add. I don't know. No, we'll just get rid of it for the speed. And then we want to change the vertical split panel, the horizontal split panel to the vertical split panel, and maybe set the split position to 70, not to 60. Then I save the changes. Then I go back to my contact browser, and you can see that everything has changed. And I haven't written a single line of Java, but I still affected the Vaadin layouts. And since such files can be stored directly on your file system, so that opens some doors. How different people, even client-side developers, can start experimenting with Vaadin and start to play around with the layouts and create something on their own, and maybe create some apps that look different. Not that I don't like content apps; they're cool, but I like when something brand new is going on. So yeah, that's about it. Go back to the slides. So if anybody wants, if anybody wants to play around with the demos, here are the links to the repositories. The app switcher is actually quite mature component, and I'm about to release the latest version that works seamlessly with at least Magnolia 5.4 and also 5.5. The rest two are demos, but I maybe will invest a bit more time in there. Yes. So to sum up, we actually managed to go through component structure, how components communicate with each other, what are the extensions. We use some JavaScript, and yes, hopefully sneak peeked into what declarative layouts in Vaadin are. I think, yes. That will be it. So I thank you for your attention.